Okay, so now we're going to go the opposite way. So for each of the following chemical reactions in molar enthalpy form, you see how it's in molar enthalpy form. 1 mole of FeCl3 gives us 1 mole of FeCl2 plus 1/2 of a mole of Cl2. There's our delta H positive. That means endothermic. Kilojoules per mole of FeCl3. We are going to rewrite this using whole number balances and energy as a term in the equation. That's a typo. Should be term in the equation. So, first thing, we are going to get them to have whole number balances. We have a whole number here, and a fraction here, 1/2. 1/2 times 2 gives us 1. So we need to multiply everything in our ratio by 2. So we get 2 FeCl3 gives us 2 FeCl2 plus 1 Cl2, and our delta H is equal to plus 116 kilojoules. Okay, now all we have to do is take this, our change in enthalpy, and put it into our reaction. Now, because the change in energy is positive, this is an endothermic reaction, so the energy will go on the reactant side. So we're going to get 2 FeCl3. I'm just going to highlight the energy going in here, plus 116 kilojoules. And that will give us 2 FeCl2s plus 1 Cl2. So those are the steps. Right now, you should press pause on the video. Try questions 1 and 2 on your own. It's important that you know how to do them on your own. Okay, so pause it and come back when you're done question 1, because I will demonstrate question 1 right away. Okay, so you've done question number 1 on your own, and you are looking to check it. So the first thing we're going to do is we look at this. We've got 1/2 a mole of H2 plus 1/2 a mole of bromine gas gives us hydrogen bromide, or bromic acid. And our delta H is negative 36 kilojoules per mole of HBr. Right? That's why this one has the 1 in it. First step, we need to get rid of all the fractions. So I need to multiply everything by 2. Right? This is just a ratio, so we can multiply everything by 2. Then we're going to get 1 H2, 1 hydrogen gas, plus 1 mole of bromine gas, will gives us 2 moles of boric acid, of bromic acid. And our delta H will now be negative 72 kilojoules. And we got rid of the per moles of HBr because now it's per 2 moles of HBr. Now this is a negative. This is a negative energy. That means the energy was lost in this chemical reaction. That means it's an exothermic reaction. That means our energy goes on the product side. So now we want to write this all into one equation. 1H2 plus 1Br2 will give us 2HBr. And then our energy is out here being lost to the environment, plus 72 kilojoules. So what this means is if we reacted 1 mole of hydrogen gas and 1 mole of bromine gas, we would get 2 moles of hydrogen bromide. This is either hydrobromic acid or bromic acid, I'm not sure. And we would get another 72 kilojoules of energy being released into the environment. Okay, so make sure you've done number 2. Make sure you've tried number 2 and come back when you've tried it so you can check it. All right, so I'm going to do number 2 right now. So here we've got water plus sulfur dioxide gives us dihydrogen sulfide, H2S, plus 3/2 of a mole of oxygen, gas. And our delta H notation is plus 522 kilojoules per mole of H2S. Notice how H2S has a 1 in front of it. We'd also say it's 520 kilojoules per mole of SO2 or 520 kilojoules per mole of H2O. But we want to get rid of the fraction first. My denominator is a 2, so I multiply everything by 2 to get 2H2O plus 2SO2 gives us 2H2S plus 3O2, and my delta H is equal to positive 1,040 kilojoules. We got a positive delta H. That means that this is an endothermic reaction. It's absorbing energy from the environment. The chemicals are absorbing energy. So our final result is that we get 2H2O plus 2SO2 plus 1040 kilojoules of energy, and we're going to give 2H2S plus 3 O2s. So our reactants had to gain energy in order to become the products. That's endothermic. All right, so those are all the questions. The readings are right there, and we are going to start actually doing these readings. You need to practice reading your textbook and doing questions from the textbook. All right, so thank you for watching.